Hello and welcome to another Java video tutorial. In this video, we're going to take a look at something called neon numbers. Neon numbers are part of number theory. That's part of mathematics. So why are we looking at neon numbers? Well, as it turns out, it's an interesting problem, and oftentimes, you might come across this question of write a Java program to determine whether a given number n is a neon number. So how would we go about doing that? Well, first of all, we've got to figure out, we've got to determine what is a neon number. We'll define that. And then what we'll do is we'll look at how we can write some Java code to check to see if any integer number is a neon number. Okay, so let's go over to our code window here and begin, defining first of all what a neon number is. Okay, so look, if you look up the definition of a neon number, this is what you will find. So a neon number, the definition of a neon number, is a number that when you square the number and you get the result of that, okay, the number that you get when you square your number n, well, the digits that make up that square added together will give you your original number n. Okay, sounds confusing, right? Well, it's not really. Let's take an example. So let's take the number 9. Let's say that's your original number n. So when you square 9, how do you square 9? Well, you multiply 9 by 9. You get 81. And guess what? When you look at the digits that form the number 81, 8 plus 1 is 9. Okay, so a neon number is any number that when squared, the digits of that square, when added together, give you back the original number. Okay, so now we know what a neon number is. How on earth would we write code to try and figure out whether a number was a neon number? Okay, so let's break this problem down a little bit. First of all, the real trick here is to, given a number like 81, how do we kind of separate the digits? How do we get the digits out of that particular number? Like 8 and 1 are two separate digits, so how do we sort of separate the digits out of that integer value to be able to add them together? Because that's what we need to do. We need to figure out, given the square of a number, when we add those digits that make up the square, does it give us back our original number? So that's kind of the trick here. How do you get the digits from 81 to add them together? And then we can easily check to see if those digits added together give us back our original number. Okay, so let's start from the start. And I'm going to write a class here called neon numbers. Okay, so I've got a file, I've got my source code file already saved. It's called neonnumbers.java, and I'm going to write, if I can spell numbers correctly, I'm going to write a class called neon numbers. Okay, inside of that I'm going to have a main, which we'll call some functions from later on. But for the moment, what I want to focus on is just this idea of trying to check to see if a number is a neon number. So what I'm going to do is I'm going to write a function to check if given number n is a neon number. Okay. So this function that we're going to write is going to basically take as a parameter an integer value, and it's going to check to see if that integer value is a neon number. If it is a neon number, it will return true. And if it's not a neon number, it's going to return false. So let's write our function. So, okay, this is just going to be like a static method inside my class here. So I'm going to say public static int, And oh, actually no, it's not going to be int. I'm gonna want to return true or false to check to see if it's a neon number. So it's going to return a Boolean value, and then the name of the function, let's call it isNeon. Okay, so we can then say isNeon and pass over a parameter and check to see if a number is a neon number. So the parameter that we're going to take is going to take an integer. Let's just call that integer n. Okay, so given a number n, check to see if it's a neon number. Okay, so we might need some kind of helper variables in here to check to see if the given number n is a neon number. So the first thing that I will want to do is I want to kind of have a variable that's going to allow me to separate the sum of the digits, okay? So for example, you know, if we have a look at our little sort of test case here, 9 is our number. So 9 squared, 9 by 9, gives us 81. So I'm going to need a variable to be able to add up the digits that are the result of squaring 9. So 8 and 1. So like I want to add up, you know, 1 plus 8 is 9. So I'm going to declare a variable here, and it's going to be an integer variable because I'm adding up integers, and the result of adding up integers is another integer. So I'm going to have an integer variable here, and I'm going to call it, what I call it, digit sum, okay, because it's going to be the sum of the digits. And then I'm going to be able to check to see if the sum of the digits of the squared number equal the number that I started off with, n. And then if they do, then it's a neon number. Okay, so since I'm going to be summing using this variable, I'm going to initialize it to 0. Okay, so this variable is going to allow me to sum the digits in my squared number. Okay, so what else do I need? Well, I need to square the number. I need to take the number n as an input into this as a parameter, and then I'm going to have to square it, okay? Because look, up here in our example, to check to see if 9 is a neon number, what we do is we square the number first, okay? And then we get the squared number, 81, and then we want to add the digits together to see do the digits make 9. Okay, so I will have another integer here, and I'm just going to call this, it's going to be the square of the number. So I'll just call it SQ for square, and that's going to be equal to the number squared. Okay, so n is the number I'm taking in as a parameter. So this is going to be equal to n, and I'm going to multiply it by itself to square it. So n multiplied by n. Nice and easy. Okay, just keep it simple. No need to call any library or math function here. We're just squaring a number. Just multiply it by itself. Okay, so that's the square. Okay, so now we've got, like, if n is 9 as an input, we've got a variable that we're going to be able to add up the digits and use that to add up the digits. And we now know what the input squared is. So 9 by 9 is going to be 81, for example. Okay, so we now know the square of the input number, 80, like for example, 81. So what do we do next? Well, what we have to do next is we have to sort of separate out the digits of that squared number, right? Okay, so how would we find out how many digits a number has? Well, there's a nice little technique that we can use to do this. If we get the modulus of the square, right? If we mod the squared number by 10, what that's going to do is that's going to tell me how many times does 10 divide into that number. And it's going to give me the remainder, okay? So if there's a remainder, we'll be left with the remainder. And then what we're going to do is, once we've done the modulus operation, we're then going to take that squared number and then we're going to divide it by 10. And then we're going to do modulus by 10 again, and then we're going to divide by 10 and then modulus by 10 again. So let's see how this works. It will work out, and hopefully you'll see what happens. We're going to need a loop to do this because we want to keep on dividing by 10 to get to the next digit and the next digit and the next digit in the number. So we'll say while the square number SQ, while that squared number is not equal to 0, because when we hit 0, because we're going to be dividing by 10 each time around the loop, when we hit 0, we're going to stop, okay, because there's no more dividing to be done. We're finished. So we're going to use a while loop. The guard on the while loop is going to be as long as that squared number is not equal to 0. Now that squared number is going to change each time around the loop. In fact, it's going to be divided by 10 each time. Why are we dividing by 10? Well, if we keep on dividing by 10, that kind of divides the number, divides the number, divides the number, and actually that will give us the amount of digits that are in the number. Okay. So what we will do first of all is we want to sum up the digits, okay? So to get the sort of end digit, we'll say digit sum is going to be equal to itself, digit sum plus, and then we're going to take the square of the number, and we're going to mod that by 10. Oh, inside the brackets. Square the number, mod 10. Okay, so let's break this down and see what's happening here. If we take the number 81, for example, okay, so there's 81, right? 9 by 9. Now, when we take that number 81 and let's say we mod that number by 10, what's that going to do for us? Well, 81 divided by 10, right? 10 goes into 80 8 times, but there's a remainder 1, isn't there? So this modulus operator, remember, is going to give us the remainder. So modding 81 by 10 is going to give us what? It's going to give us 1. Okay, if that was 82, it would give us 2 because 10 would divide into 8 evenly 8 times and it would have a remainder 2. If it was 83, it would give us a remainder 3. If it was 84, it would give us a remainder 4 and so on. See what's happening here? So by using the modulus operator and by modding 81 by 10, what that's going to do is it's going to give us any remainder digit. Okay. So it's going to give us the 1 or whatever number is in the second place here, whatever that second digit is. What about if it was 80? What about if it wasn't 81 or 82 or 83 or all the way up to 89? What about if it was just 80? Okay, well, if we modulus 80 by 10, then there's no remainder. The remainder is 0. So it's going to give us that second digit there. There is no digit really. You know, for these problems, it's a bit of a weird one. And if you look this up, this is sort of a debate over whether, well, is 0 a digit? Well, it depends on where the 0 appears, doesn't it? It depends on whether it appears before the number or after the number. But in our case, it will still work out just nicely because if we take 80 and we mod that by 10, it's going to give us remainder 0, right? So what we're interested in is capturing that 0, capturing the digits that make up the number. And 0 does make up that number, so it's going to give us 0. Okay, so if it's 80, for example, we're going to do the square of the number, modulus 10, and if it was 80, it would give us 0. So we would be adding 0 onto our digit sum variable. However, if we're dealing with 9, for example, 9 by 9 is 81, right? So the square of 9 is 81. In this case, the square modulus 10 is going to give us 81 mod 10. It's going to give us a remainder, that part in the brackets there is going to give us the remainder 1, and the 1 is then going to be added to the digit sum variable. So we're going to add on that 1 digit, okay? Got it? Hopefully that's understandable. Okay, so what we're going to do is we're going to add on the square number modulus 10. Okay, and you can see how that works with 81 because it's going to give us the remainder 1 and add it on to our digit sum. Okay, well, what do we do next? Well, if you look at the loop that we have there, obviously we have to do something to the square number, that SQ variable. We have to change that in some way, because if I left the loop the way it is, it would just be an infinite loop and it would just keep looping around and around and around, because that SQ variable, that SQ number, squared number, never changes. So I've got to reduce that number somehow. Okay, so how do we do that? How do we kind of get closer and closer and closer to 0? Well, the way we're going to do it is we're going to say that the square number equals itself divided by 10. Okay, and there's a logic to this, because if we take that square number and we constantly divide it by 10, what that's going to do is it's going to drop to the next digit place on the next digit place on the next digit place on the next digit place, and so on and so on. And it will allow us to look at each individual digit, because as we continuously divide by 10, we're kind of dropping a digit each time, right? Starting from the right hand side, working our way over to the final digit on the left hand side. Okay, so let's kind of look at how this is going to work in terms of an input of 9, and the square is going to be 81. So we add on our digit to our digit sum. We've seen that already. That's going to add on a 1 to digit sum. And then we're going to take our square, which is 81, and we're going to say that this square variable equals itself divided by 10. So let's look at that operation. What's happening there? Well, SQ, our square number, is equal to 81. Okay, so 81 divided by 10. Well, what's that? Well, 81 divided by 10, 10 goes into 81 8 times, right? Now this remainder bit, we've already sort of dealt with that, okay? And the division operation is going to, it doesn't care about the remainder. It just gives me the answer of how many times does 10 evenly divide into 81, okay? And how many times does 10 divide into 81? Well, it divides in 8 times, right? Because the 1 is the remainder bit. The division operation isn't going to give me that. 10 into 81 is going to give me a integer division of 8. Okay, so this square variable here that was 81 is now going to be equal to itself, 81 divided by 10. So now this square variable is going to have the value 8, because 10 goes into 81 8 times evenly. Okay, so square now changes from 81 to 8. We've sort of dropped that that one digit, and we're moving on to the next digit place by dividing by 10. So now square, our variable square, is 8. And we go around the loop again, and the loop says, okay, square not equal to 0. Well, remember, square is 8 now. 8 not equal to 0? Yes, it is. 8 is not equal to 0. And we go back in again. And now this time, instead of 81, we have, what do we have? Well, we have square is 8. So square is 8 now. So let's have a look at this operation. What happens here is we have an 8 mod 10. Okay. Now 10 doesn't divide into 8, right? 10 is a bigger number, 8 is a smaller number. So when we do that modulus operation and we have 8 modulus 10, what it gives us back is the remainder. And what's the remainder? The remainder is 8, because 10 does not divide into 8 at all. So it gives us back the remainder, which is 8. So this square, this modulus operation with the square now equal to 8 is going to be 8 mod 10, and 10 does not divide into 8, so it gives us back that 8 as a complete remainder, and we're going to add that 8 onto digit sum. So we've added a 1 onto digit sum previously, and now we're adding an 8 onto digit sum. Okay, so 1 and 8 is 9. Now, when will the loop end? Okay, so now remember our square variable is 8, okay, and we come down here to our division operation, and we say square, SQ, equals square divided by 10, equals itself divided by 10. So remember, it's 8 now, Okay, it's not 81, it's now 8. Okay, 8 divided by 10. It's a normal integer division operation. How many times does 10 divide into 8? Well, this division operation, remember, doesn't give us the remainder. It checks how many times one number divides into the other. And 10 does not divide into 8. 10 divides into 8 0 times. No times. It doesn't go in there. So we get, guess what? 0. So now this square variable is going to be equal to 0 because 10 does not divide into 8. Remember, we're doing integer division. So now square is 0. We go around the loop again and square is equal to 0. And our guard is checking to make sure that it's not equal to 0. So now with square, our variable square equal to 0, this guard evaluates to false and the loop finishes. And what have we achieved? Well, the first time round the loop, we added the 1 onto the digit sum. We then divided our square number by 10 to drop the digit and move to the next digit, kind of moving from right to left. And then we had an 8. And we did the modulus operation with 8, got a remainder of 8, added the 8 on, and then we divided by 10 again to get 0, and our loop finished. So in fact, we have carried out the operation to check to see whether that given number n is a neon number. All that's left to do now is return a true or false value. Okay, so what we want to do is we want to return true if it is a neon number, and we want to return false if it's not a neon number. Now, one way you might go about doing this at this point in the code is to write an if statement, okay? So what we'll do is we'll write the if statement first, and then we'll see a much better way to do this. So, you could say something like this. You could say if, and you could say, let's see, okay, so you could say if, and we'll check to see, we'll say if digit sum, okay, because remember, that's the variable that we're using. We added the 1 onto it first, and then we got the 8 and we added the 8 onto it. So we want to check to see if digit sum is equivalent to the number that we started off with, our n number. Okay, remember we took n in as a parameter here. So if the digit sum, if the digits that we got from our little operation here, if they added up and they're the same as that number that we got as an input, then we would want to return true. Yes, it is a neon number. And then we could say else. Oh, not that. Then we could say else we will return false. Okay. Now that would work. That's absolutely fine. And I think one thing about writing the return statement in this way is that it's pretty unambiguous. It's very clear what you're trying to achieve here. You're checking to see if the digits that you added up are equal to the original number, then you're going to return true because it is a neon number. Else you don't care and you return false. However, there's a nicer way to do this. You don't have to write an if statement here. Like, you're dealing with a sort of Boolean situation, right? Because this condition here, digit sum equals n, you're checking to see if digit sum is equivalent to the number that you started off with, your input n. Now, this statement itself, this Boolean expression will itself evaluate to true if digit sum is equivalent to n, or it will evaluate to false if digit sum is not equal to n. So we don't need the if statement. The if statement is kind of superfluous. We don't really need it. All we need to do, in fact, is get rid of that if block. All we need to do is we need to return digit sum equivalent to n. That's all we need to do. Okay, because this Boolean expression will evaluate to true or false, and then we will return that value, true or false. So that's a nicer way to do it. It's just a single line of code. There's no need to write an if statement. There's no need to sort of break it down into two cases. We can just return the result of a Boolean expression that will give us the answer that we want. Okay. So hopefully that makes sense. That's the function. That's the complete function. It's nice and simple. Now, why does this sort of question come up in programming? Well, you can kind of see why it's an interesting little problem to work on, because first of all, it's a nice little problem to develop a function to check to see if a number is a neon number. Second of all, it does require a little bit of knowledge of how division and modulus works in Java, and the kind of concept of integer division and using the modulus to get a remainder. And the other thing, of course, that it tests your knowledge of is, can you write a loop? Because it is an operation that requires a loop, because you've got to get, the number, you have to break it down into its individual digits, and we can use a loop to do that, constantly dividing by 10 each time. So, it's actually testing quite a lot of things here. For such a small, neat little problem, there's a lot of programming skills kind of in this few lines of code here. And it does require a little bit of thought, a little bit of problem solving. Yes, a little bit of mathematics, a little bit of understanding of division and modulus and so on. And that's why it's kind of a popular problem. You see it quite a lot on the web. It's a little test to see, can you write these kinds of functions? Okay, does it work? Well, we better test it. So let's go down to our main program, and what we can do is we can just check it against 9. 9 is a known neon number, as we've seen up here. 9 squared is 81. 8 plus 1 is 9. So it is a neon number. So let's check it against that. Okay, so what we can do is we can just write system.out.printf. And I'm going to say is 9 a neon number? And we can print out the result of that. Okay, %b, Boolean. And we'll put in a new line. And we are going to print out, we're going to call the function as part of this system.out.printf statement. So we're going to call the function in here, and we can say isNeon. Okay, so this is us invoking the function. And of course, we're going to pass over a parameter to this isNeon function. And the value that we're going to pass over is 9, because we want to check to see, is 9 a neon number? Okay, so we can save that and compile. Oh, we've got an error. Right, digit sum cannot find symbol. Okay, because I've spelled it wrong, haven't I? Yeah, okay. Digit sum. Okay, so compile's fine there. Let's run the program and see what happens. Okay, so we get an output. We get is 9 a neon number, and we get an output of true, because 9 is a neon number. Let's test it with another number. Let's say 8. Okay, let's say 8. Is 8 a neon number? Well, we can check that very quickly, can't we? Because we can say, what is 8 squared? Well, 8 squared is 64. Okay, 8 by 8 is 64. So 8 multiplied by 8 is equal to 64. Now, is 6 plus 4 equal to 8? Obviously it's not. So 8 is not a neon number, but we can test that. We can check our function to see, is it working? So we can recompile the program. And let's run the program again. And we can see that, oh, I didn't change my output statement. I didn't change my text my string literal here. So obviously we're checking 8. So let's run it again just to be absolutely sure. So we can see that the output is 8 a neon number? False. It's not a neon number. Okay. How many neon numbers are there? Like, are these a common occurrence, or are these numbers that are everywhere? Like, is it, are there more neon numbers than just 9? Well, I suppose you could run a little experiment to figure that out, couldn't you? So let's actually write a loop. Let's write a loop to check how many neon numbers there are. Let's say what we won't check how many there are. We'll print the neon numbers between let's say 1 and 1,000. Okay, let's start with that. Okay, so we need a loop. I just want to repeat something 1,000 times, so I'm just going to use a for loop to do this. So I'll say int I equal to 0, I less than 1,000, I plus plus. And what we're going to do is we're going to say, let's see, what will we do here? Well, let's write an if statement. We'll say if is neon, and we'll say I. Okay, so the I is our loop counter variable. It's going to start at, I said 1, didn't I? So I equal to 1. If is neon I is going to start at 1, and it's going to increment by 1 all the way up to 1,000. So that's actually, I could say less than or equal to 1,000 to get it to 1,000 exactly, and then I can pass over I to my is neon function. So remember, that's going to return true or false. So if is neon returns true, I don't have to put in the true there, but that's really what's happening here. If is neon equals true, okay, I don't have to put that in. I can just say is neon, and if it's true, it will execute this branch of my conditional block. Well, then I can print the number. So I'm just going to print the number. I'm going to print I. So system.out.printf, and I can just print I. So I is an integer, %d, followed by a space, because if there's other numbers that I'm going to print after it. I don't want to print a new line. I want to print them all on one line. So that's fine. And I can just print out I. Okay. So if it's a neon number, then I want to just print it out. Do I need an else? Well, I don't really need an else, because if there's an else there, I don't want to do anything. So, like I'd be just, putting something like this in, like skip, or, do nothing. So it's a bit redundant, really. So I don't need it. I can just take that out. But what I might want to do is, after this loop, I might want to just print a new line. So system.out.println, and I can just print a new line like that. Okay, let's save our code and compile. Hopefully we've no syntax errors, which we don't, and we'll run the program. And what do we get? What do we get? What do we get? Oh, okay, right. We get 1 and 9. Okay, we get 1 and 9. So remember, what are we trying to do? We're trying to check to see how many neon numbers there are between 1 and 1,000. Well, guess what? There are only 2, 1 and 9. They're the only numbers that fit the criteria between 1 and 1,000. Okay, that's interesting. What about between 1 and 10,000? Maybe there are more there. So let's change that, and we'll recompile and run our program. How many are there between 1 and 10,000? Actually only 1 and 9 again. This is interesting. Maybe they're not as common as we might have thought to begin with. Okay, what about between 1 and 100,000? Okay, let's compile this and see what happens. Okay, let's run that. Well, only 1 and 9 again. Well, I'm not going to keep going because as it turns out, neon numbers aren't that common. In fact, the only known sort of neon numbers, within any sort of reasonable range are 1 and 9. Okay, they're the only neon numbers, that we could check feasibly with a little program like this. So neon numbers are not common. 1 and 9 are the examples of neon numbers. So what use are neon numbers if there's only two of them? Well, actually, they're not really that useful. They're sort of just oddities within number theory. But what they do give us is a nice little problem to work on and a nice little Java program to write, which includes a little bit of everything, a little, variables, loops, some modulus operations and some division operations. And it's a really nice opportunity to kind of learn how those different Java topics actually work to solve a problem. So hopefully that was useful to you. Hopefully you found it interesting. If you did and you like this kind of content, please subscribe to the channel. It really helps. And please give the video a thumbs up. And if there's any other content that you'd like to see me cover, little examples like this, for example, let me know in the comments. Thanks a lot. Thanks for watching.